Greetings, the Astro 30 here, and I have a bunch of kits in front of me, all of which I didn't really want. I'm still waiting on a preamplifier, actually two that I ordered months ago. They still haven't arrived. So it's sort of halted production of making this amplifier. However, I do have one part here that I do need, which is the signal input selector. Now I have three different kits, or three different versions. Now the first version I received a couple of days ago is this one. It uses PCB mounted RCA sockets there, and if we have a look here, this is the printed circuit board. It's reasonable, but it doesn't leave you a lot of options for mounting said board. I don't really want to do what I did with the test amp and have to measure and drill the RCA sockets and the screws to hold it. The only problem with this board is it uses surface mounted diodes for the full bridge rectifier there, and they're actually quite badly soldered. Yeah, it looks like they've just scraped the soldering iron over the top of it. So this one I won't be using because I don't want the bridge rectifier, I only just want straight DC. That's the plan anyway. So that kit's not really much good. I've got this one, but unfortunately it's pre-assembled. The only assembly parts you've got to do is the LEDs and the terminal headers, but the rest of it's all pre-soldered, which again I don't like. And if we take a look at this circuit board, see, that again is poorly soldered. Don't know how well that's going to come up, but look at all the white residue and flux, and oh, it's just nasty. And the diode here isn't even soldered properly. That is poor workmanship. And see, the thing is, I'd need to mount my RCA sockets on the panel and then solder the board to the sockets from the front, and that gets awfully awkward and messy, calculating distances between the standoffs and things and getting everything to line up properly, and these spacings are all kind of weird. They say it's about 26 millimeters across there and 20 millimeters that way. There's no exact measurement here. So yeah, this one I won't be using either. That is the switchboard come LED, and yeah, they're only 10 mil apart, but they're very closely spaced, and this one doesn't even use a terminal header or plug connector or anything to connect the wires. It's just straight solder wires to it back and forth, and that looks, yeah, ugly. So that's one I won't be using. And also with this one, you can't have the facility of LEDs to indicate which channel is selected. So that's the other reason I'm not using that one. And this one, well, it's just poorly done. So that can just go away. So that leaves us with this last final one. This one comes from Jim's Audio. Not sure who makes it, he just sells it. But it's a complete kit. You've got a PCB completely bare, and it's of yeah, reasonable thickness, about 1.5 millimeters, somewhere like that. Doesn't flex too much. And of course the bag of parts. Now it does come with a rotary switch with a spline shaft on it. I actually have a rotary switch with a flat shaft on it, which is one I'm going to be using. And it's got green LEDs, but I'll be changing them to blue LEDs. And there's no schematic available for this, but it's pretty basic. And your LEDs all mount here, so I'll put plug headers here so that they can actually go to the front panel. Now, how am I going to mount the LEDs, I may hear you ask? Well, I'll just simply hot glue them to the inside of the front panel. And this uses 1N4007s for the bridge rectifier, so all I've got to do is just bridge across 2 of them with some link wire. Has its own 12-volt regulator on it, even comes with a heatsink. And you've got 2 options for mounting the input connectors. You can just use these 2-way terminal blocks like that, or as that other kit has, those PCB mount RCA sockets. Now the pin spacings are here a little bit how you're doing, so that when you mount the socket it sort of goes over at an angle. This is probably the better option, but the holes are really large. And the other thing is, I've got no access to this ground here. There is a signal ground point over here. That means you have to run a wire to your array. Yeah, okay. It's a little bit how you're doing. So how I'm going to mount the input sockets, I might just use audio cable and just hardwire them to the board. That way I have a separate ground for each. I don't know, I'll have to decide that. But as I say, there's no schematic to this, but it's pretty simple. But I'm pretty sure that a lot of you want to know how this works. So let's have a look at that. Alright, so it's not that complicated. You have a 12-volt rail there. That comes in through your rotary switch, which is a 4-way. Like so. So that's your rotary switch. That selects which input path you want. And that simply just switches the 12-volt through a relay coil. And there's 3 others of them as well. We also have our back EMF diode, and we also have a resistor which is 4K7, which then goes through our indicator LED, and that's basically it. And of course the relay contacts for each relay select your input. I'm not sure whether it's common out or switched out for where it joins to the audio path, but it doesn't really matter. We could say that that is our left in, right, try that again, our right in, this would be right out, and that would join off to the next channel, and the next channel, and the next channel, and this would be your left out, and that would also join to the next channel, etc. That's basically all that is. And the reason why you'd use an input selector that has a switch that switches DC to relays is you want to keep your audio leads from the source as short as possible. So you don't want, like, normally on an amplifier your inputs are at the back of the amplifier and the selector switch is at the front. You don't want to have all these signal wires, like, you know, 400 millimeters, 500 millimeters long length of wires running from the back to the front to the switch and then back out to the preamp again, because there is a good chance you can actually pick up noise that way. So this is the reason why we would use one of these input selectors. So at least it gives me something to do today. I'm hoping the preamp comes today. I've been waiting well over 2 weeks from the time it should have been here, and I'm getting slightly annoyed. But at least it gives me an excuse now to do the back panel, like drill it and so forth, because this will be mounted to the back panel, and the voltage wire for the selection will be going to the switch for the front, and then shortest possible wires to the RCA sockets. Now with this connector, it's a 5-way. They do supply one, but the one I've got is a 6-way because I have to wire my own cable. So I'm going to have to remove one of the pins to make it fit in this board because, well, this has only got 5 holes on it, not 6. And I received the Electra set to do all the panel labelling. However, it is a little on the large side. Some of it has actually come off on the backing here, I've just noticed, but it should still work. That was only a weird symbol with a slash through it, so that's not really all that important. Yeah, so that gives me an excuse to drill and label the front and rear panels as best as I can. Yeah, so that's going to be the plan for the day, is to do that. Hopefully this Electra set is still okay, because I haven't seen Electra set in years. They haven't made it in years. So this would probably be around 20 to 30 years old, somewhere around there. Anyhow, so that's the plan. I'm going to make the circuit board up, and yeah, I've got the panel art for the rear panel in the design software ready to print out as a drilling guide at least. I've got the hole centers here marked out, well, measured out anyway, so I know how wide and where to put them on the panel. And yeah, I've still got that varnish spray, so all I need to do is just do a little soldering and do a little hardware. So I might do that in time lapse. It's a simple circuit to assemble. It shouldn't take any more than about 15 minutes. Okay, that only took about 10 minutes of time to assemble. It's not that complicated. I've got up to the part of mounting this 12 volt regulator to the heatsink. Now, they don't provide any isolation, but you probably don't need it, but you will want to smear a little bit of grease either on this surface or that surface before mounting it to the heatsink. And it goes in the board like that. So what I would do is I would take a bit of heatsink compound. So we take this provided screw, the device, place the screw and device together, grab the heatsink, and now I'm just going to get it started in the heatsink, do him up. I'm not going to, well, I can probably guess and torque it to where it needs to be, as long as it's relatively straight. Yeah, that should do him. Tighten him up. Now, these capacitors here only had like 5mm leads on them, like length, which is strange. It's unusual for a new capacitor to be like that, but oh well. So now I'll place the heatsink and device in there now. There is an issue I have just noticed immediately. That screw is coming into contact with that capacitor. Now, according to what's printed on the board here, it's supposed to be 100 microfarad, and they've got a 220 50 volt for some reason. So what I might do is, because, well, that way is fine, it's not coming into contact with the first one. I'm not happy with that second one, so I might remove him and change him to, well, what the correct value should be, which is 100 microfarad, but I might use like a 16 volt one, because quite frankly there is no need for a 50 volt capacitor there. Saying that was relatively plain, and it's brand new, I can still reuse it. Okay, so there's my 100 microfarad, it's very small. So now that screw is not going to interfere with that capacitor. So I'm just going to first solder one of these locator pins to hold the heatsink in place. Then solder the device. And frankly, my soldering is a lot better than the pre-assembled one. It's taking a little bit more heat and effort because, well, it's connected to a heatsink now. Make sure that's soldered properly. So that's soldered in. I can trim off the excess, and this, I forgot to mention, is a single-sided board, so removing components off it if I have to change them is going to be a lot less effort and a lot less stress on the circuit board to do. So now I need to put in the headers for the LEDs. So I've got 4 of these two-way angled ones, which would, when in the board, would look like, you know, something like that. But because the board is going to be mounted vertically, that's not going to work too well. And plus I don't really want it that way around, I want it that way around. So all I have to really do is just simply straighten the leads back out till they're 90 degrees, place them through the hole, and then turn them into a right angled mount. And yes, I know what you're saying, why didn't you just get ones that stood straight up? Well, they didn't have any, they only had the right angled ones. See, it's easy to turn a right angled connector into a straight connector than it is to change a straight connector to a right angled connector. So that's all them 4 in place. Okay, post has been today, still no preamp. I'm getting slightly frustrated. So I'm going to move on to adding, well, at least the now DC connector, which has got really large holes on the PCB for some unknown reason. and the signal output connector. See, my solder joints are a hell of a lot better than the pre-soldered module. So if we look at that, mine are a lot more cleaner, and there's no excessive white burning. That white stuff you saw around the joints was where they had applied the soldering iron, the heat way too long. So back to what I was doing, finding out which one was negative. So there's the negative of the cap there, which is there, which goes across this pin here. So I need to mark that pin as negative with a blue mark, even though the connector's blue. So, but that still gives me a relatively good idea of what's what. So I'm just going to take a piece of wire I use in the breadboards, just pin the end because I think that one was going to break off anyway, and I will cut that off. Now I'll take it from the output of the regulator, across the capacitor, probably be a better place to put it. I'll put it across the capacitor, and then I can just simply touch this to where these things need to connect to turn each relay on and off, and see if it works properly. So that's what I'm going to do now. Okay, I've got the power supply set to about 15 volt off to my left here. Got the negative hooked up, the positive hooked up. Just going to double check that that's hooked up correctly, because nothing worse than turning it on and blowing capacitor sky high. So that's that one there. It comes in through here, comes out there, goes to the ground point of the regulator and the negative of that capacitor. So that should be the correct orientation. So I'll turn it on, and not much is happening. So I'll just touch each individual relay. There goes 1, 2, 3, 4. So I guess you'd want to see a little light, I suppose, light up as well, because I haven't got any soldered in. So I'll just grab an LED that came with the kit, and we'll see if it lights up. It should do. Now, my cathode is on the right, so that's the shortest one. So I'll just bend that in such a way so we can see it. Hopefully you can see it. See, it lights up. Next one. Lights up. Next one. Lights up. And the last one lights up. Now that's alright for a green LED, but I'm going to be using blue ones. So how bright are the blue ones compared to the green ones? Now that is significantly bright. Probably a bit too bright. But it looks okay as far as I'm concerned. Okay. Nice. What next, I hear you ask? Well, I can take it out of the mount, and I can put my tool away because I don't need him anymore today, and I'll move the power supply in a minute. That just fell out, that's fine. It's got to come out anyway. So take that one out. Now I need to mount some screw standoffs and actually get the rear panel art printed and ready to stick onto the back panel of the amplifier, so I can commence drilling. Okay, and a short time later I've got the thing printed out. As you can see, it's on 2 separate bits of paper, so I'm going to have to join them together, and the easiest way is I'm going to cut one of these edges off with the marker lines here and then line it up with the marker lines on this one and sticky tape it together. Okay, as messy as that looks, I was having trouble getting the tape to stick to the panel properly, so I've just gone and wrapped it around a few times here just to keep it on there long enough to actually drill and especially cut out this. So I'm just going to add one more final piece of tape on the edge here just to try and keep it as tight and flat as possible. It only has to stay on there long enough to mark out, like center punch, drill my pilot holes and cut out this, and then all the rest of the holes can be drilled up to size without the paper on it. Okay, I got it in the drill press. Now you really should clamp it. That's what you should do. Got a 2.5mm drill bit. The holes are all center punched. So okay, and so there's all the pilot holes drilled. Now luckily there's nothing really alignment critical except for the mounting holes for the socket for the speakers and the PCB and the IEC. The rest, if the holes are slightly off center, it's not the end of the world, it's not overly critical. They look all relatively centered to me. A couple went off here and there, but not too bad, by about 1 millimeter. As I say, you're not going to see these ones here. But now that all the pilot holes are drilled, before I completely lose my piece of paper, I'm going to get out the angle grinder and I'm going to grind out the hole, the square hole for the IEC socket. Then I can take the paper off and then drill up all these holes to the correct sizes. At the moment they're all at 2.5. Right, so now's the fun part. Okay, I've moved outside because this angle grinder tends to send dust and crap everywhere. So it's also clamped to the drill press. Okay, well that's the hole cut. Had a little bit of war wounds there. If I rip the paper off, you can see, yeah, there's a little bit of damage to there, but it should still be relatively alright. I'll just get the part. I think the edge of that is just going to cover that little nick anyway, and all the edges of the component cover the rest of these. So all I've got to do now is fold that out so the component fits, and then we can move on. Okay, it's a nice tight fit. That's what she said. However, it doesn't quite cover that little accident I had, but yeah, being the back panel, it's not going to be seen all that much. However, I can see the overcut on this side at the top. You know, it is what it is. As I say, it's the back panel, but this is why you have to be very careful when doing things, because you've got to get it right the first time, or else it's going to look like shit. Thing is, this doesn't really particularly matter too much. As I say, you're not going to see it, so I'm just going to leave it as it is. It fits, that's the main thing. Moving on. So next I need to drill out all the holes to the correct size. So first I'm going to size up all the holes that need to be drilled to 3mm, which is these 4 here, and these 2 over here, and these 2 here. Now to do the RCA sockets, and I'm deliberately not using a block of wood underneath it, as long as I don't really do too much damage to the panel. I'm going to drill these to 6. So, but you should really clamp the work. So, yep. 6mm is the right size hole. I'll deburr them after I finish drilling all the rest of the 9 holes. There's the holes for the RCA sockets. That one's slightly off, but yeah, it won't matter. That's pretty good. It's all deburred on this side. Need to deburr these connections. But basically now I'm going to drill out the fuse holder, these holes for the speakers, the pins on the connector to go through, and deburr the edges of these and just make sure that these are deburred. Short time later, all the holes are drilled and deburred. That's the reverse side of it. So now it's ready for some labelling. Okay, so unfortunately the Electroset will not stick to this panel because it's too rough of a material. There's a slight bow on it too. So what I'm going to do is do it the way I was going to do it, which is print it out on little labels, cut it out, stick it down, and it's not what I wanted to do, but it's the only way it's going to work because this material is too rough for the Electroset to stick to, unfortunately. Okay, as bad as that looks, it looks like I bought one. No, not really. Got all the labels on, just marking out what each thing is. They're a little bit all over the place, but what can you do? And I don't think I'm going to be able to get the Electroset to go onto the front panel either because of the same problem. Yeah, that has the same texture to it. So that's a bit of a bummer. So what I'm going to do now is I'm going to spray this over with some protective lacquer just to more or less protect the toner more than anything else. And hopefully they don't come off for a while. I've got it sprayed and I'm now just baking it in front of the heater there to, well, make it dry a bit faster. Should only take about 15 minutes, I reckon, just so it's touch dry. I'm only going to give it one coat, that's all it should need. Yeah, so I'll come back once that's gone off a bit. Alright, there's the panel about half an hour later. It is touch dry, but it's extremely hot, so I've got to let that cool down a little bit. Doesn't look too bad. It's shiny. I decided to go with the connector that comes with the kit for the switch because I measured this out. It is just long enough. However, instead of having my LEDs at the bottom and the inputs at the top, I'm probably going to turn it around 90 degrees, sorry, 180 degrees. The LEDs are at the top and the input connectors at the bottom, so that the switch is closest to this edge as possible, so it's only got a short distance to run. I also took the liberty of wiring the speaker socket up with all the leads on it. I still need to put PTCs on the end of it, but that's not a big great issue. Yeah, there's one little bit of insulation there that melted slightly, but we're almost nearing completion of this project, and I'm extremely happy. A little bit of junk from the sprays coming back off. So let's just bask in its glory for a few minutes. No, let's start mounting some other hardware. I'm going to drill those out just slightly because it's not going to fit quite properly that way. So I should be able to pop that out. Okay, so yeah, drill. Okay, I'm going to drill them out to 3.5. Just give it a bit more wriggle room. Just got to watch that transformer at the back there. Should be fine. It's not burnt on the inside, so that's fine. Kick the tripod yet again. Whoops, I just scratched the shit out of it. Didn't mean to do that. It's only a small blemish. This is probably why you shouldn't do things live on camera at the same time. It's only a small scratch. As I say, it's only the rear panel. It's not really that great big of a deal. Now for the fuse holder. So it's going to be probably just a slightly tight fit, which it is. It's not quite fitting in the hole. That'd be right. It's a little bit too small. That means I need to file him out. Okay, a little adjustment with the file later. So I need to get to both of these terminal tags, so I'll mount it that way up. I'm just wondering if I've got enough meat to do that nut up properly. Soon find out in a sec. Okay, that's the fuse holder in. Had to get a little bit aggressive with him. Might as well pop a fuse in, 5 amp slow blow. So that's all ready to go now. Okay, got a fuse in. Might as well pass this speaker connector through. So I'll start with each wire individually. That was alright, there was a bit of burring on the outside anyway. So this should now hopefully fit in the hole properly. This is probably going to be a fairly long video as well. Sorry about that in advance. But as I did apologise once before about a video being too long, a viewer just commented the comment, it takes as long as it takes. So, and they watched every minute of it, so they liked some of the information in it, I guess. So that's the speaker socket installed. I suppose to put all the RCA sockets in now. So these have a nut, a shake-proof washer and the tag. So I'm going to use all three. The tag goes on first, the shake-proof washer second, the nut last. So that goes through the panel like so, and then we just transfer all the guts back on to the back of the I was going to say pot, that would be wrong, the RCA jack, and then just go along and do the same for the rest. Okay, that's the RCA sockets in. Don't know if you can see on camera here or not, but I've got wire joining the two tags together between each set of RCA sockets. Reason for that is to hold these tags still whilst torquing the nut, and another reason is to give me a point here somewhere to solder the shielded section of the wire I'm going to use to, because it's then going to be going to the bottom of this circuit board over here, and there's no way of really getting an earth point in there unless I put it through the small hole, but it's only a small hole, or then just run the signal ground back up to here. I haven't decided yet, but this cable is long enough just with it in that orientation. In retrospect, it probably would have been a hell of a lot easier doing all this with the panel off, because tightening those nuts was awkward. Well, I did it, but it would have been a lot easier with it off. I should have put all the hardware on with the panel off. And just for future reference, that's for next time, that's exactly what I'm going to do. Just one other thing, I have actually tied the earths for the speaker socket to the star point. Yeah, so that's ready to go. I'm not sure how I'm going to route this this left and right cable around, because that needs to go over to, well, this side where the headphone socket is sitting just out of shot, because it's got to be wired to the back of it. I could probably run it around that side of the case. I just want to try and keep it away from the mains wiring and the secondary wiring, so I might actually bring that up across the rail and back around the very top. But I'll decide that later. Anyway, this project's coming on. A little disappointed I still haven't received either of the preamps I've ordered from about a month and a half ago, but at least I did something constructive today, and I've got the back panel all drilled and all the hardware mounted, and it's starting to look sexy as hell. You haven't seen the back of it yet, have you? Well, you have, but you haven't seen it with the RCA sockets on. So that's our input section plus the preamps output, our speaker output, left and right obviously. I've marked it as 8 ohm, we'll leave it at 8 ohm only. And of course the mains input. Now none of that wiring is done yet. I even have a condom for the IEC socket so that we can actually stop accidental electric shock. It just slides right over the device. It's a bit tight. I think that's the small one. I should get the bigger one, that probably fit a bit better. I'll have a look in J-Car next time I go down there. It's just a little IEC socket condom. Protective rubber. Yeah, but it is awfully stiff to get on there. So anyway, I'm going to put my condom away, and I'm going to end this video here. I'll work on it some more another day. I think it's time for a celebratory drink for all that hard effort that I put in today, because doing hardware and drilling panels does take quite a considerable amount of time. Especially if you want to do it and do it right and not mess it up too much. Yeah, sure, I had a little bit of an accident. You get that, but that's why you get a second panel. If you're not going to use it as a sub panel, you can redo it, but I didn't want to go through all that rigmarole of redoing it, negating the sub panel, and yeah, you know, whatever. So for now, that's where I'm at, and that's where I'm going to leave it. So I'm going to go have a beer now, and I will catch you in the next episode. Thanks for watching. I'm the Astro 30, and as always, if you like this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyways, this is the Astro 30 saying, see ya, have a great day, and I'm not your Darlington.